All right, so today we'll continue our discussion of absolute functions. So the more lengthy part in the first lesson, which was parent graphs for the first time, the shifting, the reflecting, all of those things that we do to a parent graph when we transform it using our equation. Today we're going to look some more at our graphing calculator and graphing absolute value functions. One thing that I do want to point out about absolute value functions that I don't feel like I stressed really well in the first lesson is that absolute value functions, I said it in the definition that they're a type of piecewise function, but I want you to see why they are a type of piecewise function. If you have the parent graph for absolute value, which we already discussed looks something like this. This is a piecewise function because you could write the equation in two pieces. You could look at this piece first and say, well, that's the line because a parent graph has the slope of -1 there, that's the line y equals -x. So we could write the first half of the piecewise as -x if x is less than or equal to 0, because it comes to this point, this would be a closed-in circle. Then the other half would be f of x equals positive x, because it's a slope of +1 on this side. And if x is greater than 0, remember only one of them can have the equals. Now you could switch which one has the equals and they would both be, it would be correct that way too. So I just wanted to make sure you understood why absolute value functions go with piecewise. It's because we could write them as piecewise functions, but that would take us a lot longer than studying the actual parent graph. So, in order to graph absolute value functions on your calculator, we probably should know what buttons to press, and I briefly introduced this when we did our Intro to the Graphing Calculator worksheet. So if you're looking, I've got a picture of the graphing calculator up here. If you're looking at the graphing calculator, in order to graph this, of course, you need to be in your y equals screen, so this button right here. Then to get the absolute value function in, you press the math button, so this one. Then it'll bring up a menu where it says NUM along the top row, so you'll press your right arrow key to select the NUM menu, and then you'll select choice 1, which is absolute value. Make sure that you close the parentheses if you have an older 84 or an 83, because your closing parentheses close the absolute value bars. If you have a newer model 84, instead of showing ABS on the screen, it actually shows you the bars. So those, you just have to be careful to make sure that you're really typing what goes inside, inside, and what goes outside, outside by using the arrow keys correctly. So we're going to learn some new functions today too, and we're going to learn how to use the trace and value feature. So I'm going to show you that in example 1, but you can see up here that I've got the keystrokes that you're going to press in right there in your notes. So if you forget, you can always go back and look it up for how exactly you need to press those buttons in. So when we are using the graphing calculator, so we're going to look at example 1, use the graphing calculator to graph the absolute value function, then use the trace feature to find the corresponding x values for the given y value. So here's my equation, y equals absolute value of x plus 14. Eventually it wants me to find the x values where y is 9. So on my calculator, you'll press your y equals, then, so I'll write the keystrokes down for this specific one, so y equals button, then you are going to hit math. Then you're going to scroll right to the NUM, and you're going to choose choice 1. That should either bring up the absolute value bars or bring up something that looks like this, ABS parenthesis. and then you're going to type what goes on the inside. So in this case, x plus 14. If you have the old version, 83 or 84, you have to close the parenthesis. If you have the newer 84 where it has the bars instead of the ABS, just scroll to the right so that your cursor goes outside of the parenthesis. Now, when you are graphing this, we probably don't want to do the standard window because it says that the equation is y equals x plus 14. If we were using what we learned yesterday and graphing this by hand, we would say that this equation shifts left 14. We know that it's the same width as the parent graph, which means that its slopes, because my a value is 1, so my slopes of my rays are going to be 1 and -1. It opens up. So if I were graphing it by hand, which obviously you have to sketch the graph here, I would say, okay, I need to go to the left 14, so I can't count by ones. I don't have enough room on this graph. So I'm going to count by twos. So -2, 4, 6, 8, 10, 12, 14. That's where my vertex should go because it said shift left 14. My slopes, it's the same width, so that means one of my rays, if it's opening up, I go up 1, right 1, up 1, right 1, so on and so forth. And I continue that all the way off the page. And then on the other one, I go up 1, left 1, because that is a slope of -1. So what I can see on my sketch looks like this. Now, if you want to adjust your window on your graphing calculator to make sure that you can fit all that, you may have to guess and check a little bit. Now, yours may not be the same as mine as far as the window, but the key is that on this sketch here, we can't see the entire left half of that V shape. So that's what we want to focus on, is being able to see more of it, because what it is asking us to do here is to find the x value when y is 9. Well, when y is 9, if I pull up just on my picture here, 2, 4, 6, 8, 9 would be right here. Well, one value where y is 9 is right here, but notice that on my sketch, I can't find the other one. It's over here somewhere. So this is a feature where our graphing calculator can really help us out, but only if you've got the right window. So in order to see the entire V, I did my window, my x minimum, I went from -30. My x maximum, I only went up to 6 because you didn't need to go very far to see the whole right side of the V. My x scale, I counted by 2s. You can certainly count by something different if you want. Again, because my vertex is on the axis, you don't really need to go much below the axis. I always go a little below what I need. So I made my y min -6, and I made my y max 30. Again, on the y's, I also counted by 2. So this is the window that I used so that you can see the full V on both sides. If you cannot see the full V, you're not going to be able to do the next step. So if you need to pause this, fine, but you need to adjust your window so that you can see the entire V. All right, so now to figure out how to use the function that it wants. If you can see the entire V, you should be in good shape. It says then use the trace feature to find the corresponding x values for the given y value. So again, what that's telling us is it wants me to find the x values where y is 9. And one of them, 2, 4, 6, 8, 9, I can kind of guesstimate, but my calculator is going to give me a better guesstimation than what I can see on that graph. So the way that you do that is right here. So you need to press the trace button. It's in the top row right next to graph. And you can see it brings up like I call it the blinky. It's a blinking cursor, And you can use your arrow buttons, so these ones up here, to scroll to the left or to the right and change the values. So as I scroll right on mine, my y value gets bigger. Now, you're not going to probably be able to get it to say exactly y is 9, and the values are at the bottom. So if you're looking at your screen, you should see, and I'll try to draw it on here, but you should have your v, oops, it's not going to let me draw there because it's not on my PDF. You should have your v there, and then you're looking at the very bottom of the screen. It'll say x equals, and it has decimal values. So continue to press your arrow button until you get y is approximately 9. Now, some of you may have chosen a point that's just below 9. So if you did that, you should have something close, and your values may not be exactly the same as mine. But what mine have for on the right side of my v over here, it says x equals negative 5.106 approximately, y equals 8.89. So I got very close to 9. 8.89, and my x value was negative 5.06. Now, some of you may have gone just a little bit above 9, and you're looking at the point x equals negative 4.723, y equals 9.27. And again, yours may be a little, above and below those. They won't be exact on everybody's calculator. But here's the trick. If we want y to be exactly 9, we know that our x value is going to be between negative 4.7 and negative 5.1. So if you are making an educated guess as to the value, the actual value when y is 9, hopefully you would guess that x equals negative 5. So that's going to be our first guess. Now, we can make an educated guess, but we need to confirm it, and that's what I have here. To verify the exact value of x, you're going to press the second button, this one, then press trace again. So second trace, and then you want to choose choice 1 because that says value. When you do that, you should, at the bottom of your graph, have x equals and then a blank blinking cursor. You need to tell it what value of x you want it to confirm. So press in negative 5 and press enter. And it should now pop up at the bottom, x equals negative 5, y equals 9. So that means we have confirmed using our trace and our second trace that x is indeed negative 5 when y is 9. Now here's the trick. That's not the only place on this function where y is 9. We have to find the other one too. So on your v, it's over to the left side. So go back to the trace button, the plain trace, not second trace. So just press trace again. It should bring your blinking cursor back, and continue to press the left arrow button until, and if you hold it down it goes faster, until you can get close to 9 as your y value on that end. So when you were doing that, if you were a little to the left, you would have maybe something like x equals negative 23.106, y equals 9.10. If you were just to the right of it, you might have x equals negative 22.72. where y equals 8.7. So again, we can look at this and we can make a very educated guess. If it's between negative 22.72 and negative 23.106, we can probably make an educated guess and say that we think x equals negative 5 and x equals negative 23. Again, confirm, verify that by pressing second, trace, choice 1. This time we're entering the value negative 23 and pressing enter. And it does say 9, so we know that these are the correct solutions here. Now, if you wanted to just do the trace first for both of them and then confirm both, you don't have to keep pressing second trace. Right now, if you haven't pressed anything else and it says x equals negative 23, y equals 9 at the bottom, you can confirm a second value without hitting second trace again. Just type in, it says you can verify as many values as you want by simply entering the next number. So if I wanted to check when x equals negative 14, because I know that that's my vertex, I can press in negative 14, enter, and it'll pop up x equals negative 14, y equals 0. So you can verify multiple problems at the same time. All right, so that is how to use our graphing calculator, trace and second trace features, and how to graph absolute values. Our second learning goal is I can use the graph of an absolute value function to write its equation. And in order to do that, we are looking at working backward again. So we're using the same information from yesterday, this equation right here, the a absolute value of x minus h plus k. We're just going to work backward. Remember that the vertex location, because you're looking at the picture, where the vertex is, those are going to tell you the values of h and the values of k. H, remember, is the x coordinate, and k is your y coordinate. So, if you look at the h and k, or if you look at the vertex, that's going to tell you h and k. In order to find your a value, you have to do two things. First thing you have to do is you have to check to see what the slopes of the rays are. So you're going to be counting rise and run, just like we did with the piecewise functions where we were working backwards. You're going to count rise and run. That tells you the value of a. So is it 1/3? Is it 2? You know the sign of a, meaning if it's positive or negative, based on the direction of the opening. So the direction of the opening is going to tell you whether that a is positive or negative. So if it's opening up, you know that the a value is positive. If it's opening down, you know that the a value is negative. So now let's practice that. So here we have a lovely absolute value function, and again, you could write this as a piecewise, but absolute value is a little easier. So first thing, identify my vertex. Vertex is right there. That is at the point 0, 2. So that means h is 0, k is 2. So if I'm plugging it in to my y equals a absolute x minus h plus k, I am saying that I know it's going to be y equals absolute value of x minus 0 and then plus 2. Now, I also know that I don't need minus zeros, so I know that this is going to be, I'm leaving space for my a value, x, and since I don't need the minus 0, I'm just going to close the absolute values. My plus k, in this case, is plus 2. So now my a value, I need to count the slope. So from my vertex to the next solid point that I can see, I rose 1 and I ran 2. A rise of 1 and a run of 2 means a slope of 1/2. So a value is 1/2. To know whether the a is positive or negative, I look, this opens up, so it should be positive, which means that that one is finished. So why don't you try this last one? Go ahead and try to write its equation. So pause it for a second and then unpause it to see if you can do this correctly. So first thing I do is write the vertex coordinates. That is at -2, -1. So h, k. So now I need to plug that in. So y equals, I'm leaving space for my a value. X, remember it's minus -2. When we see our x's in the bars, we change and go the other direction. So this is going to be a plus 2. Outside of the bars, we can stay where we are. This stays a -1. Now I just need my a value. So count, rise, and run. Here's an exact point. Here's an exact point. So from these 2 points, I rose 3, and then I went left 1. So I went up 3 and to the left 1, which would be negative. So slope of this particular ray is -3. Now, to make sure that negative is what I actually put in my equation, double check. This does open down, so it should be a negative value that goes out in front. So y equals -3 times the absolute value of x plus 2 minus 1 is your equation. And that is it for this lesson.